Our next speaker is Bob Dickey, again late of FDA, but now at University of Texas.
Good morning, everyone. And thank you, Nancy and CRRC, for the invitation to join this august group. I appreciate the opportunity to be here and provide a bit of a retrospective on the seafood safety concerns of the oil spill. This is just one of many, many facets of response involved in responding to oil spills in the environment, especially the marine environment. A little bit of a backdrop. In April of 2010, I was on detail, or TDY, to College Park, Maryland at the Center for Food Safety and Applied Nutrition to work for the Senior Science Advisor for the Center Director when the spill occurred. My home is on Dauphin Island, Alabama. South side of Dauphin Island, about 60 miles north of the wellhead. And so by the time I made it back to Alabama after my detail was over, I got to help get the response going from an FDA perspective in DC. We were smelling the oil very, very clearly coming out of the hole in the Gulf of Mexico. So that provides a little bit of a qualification of the impact, or at least my involvement and my location. FDA happens to have a seafood safety and technology laboratory on Dauphin Island. I was the division director for that laboratory at the time, so I was returning to my post and picked up the ball in terms of seafood safety. Responsibility for seafood safety at a federal and state level looks like this. State agencies, of course, are responsible for their territorial waters. NOAA regulates the federal waters, and they are, 3 miles from mean high tide to 3 miles out, and then except for Florida and Texas, which claim 9 miles. And then FDA is really involved in the interstate commerce of seafood. We were responsible for the seafood safety, the safety of the product crossing state lines. And so the three entities work very closely together. Being the second largest spill, now I learned, thanks to Gary, in the United States, it involved many entities, and it was a very, very complicated mix to get everyone rounded up, organized, get the toxicologists together, all the different agencies that were responsible, different facets of the response together, and pushing and moving in the same direction. But in considering seafood safety concerns for any potential contaminant, the first thing we need to worry about are the identities of the potential toxicities of the compounds involved that might contaminate a foodstuff, in this case seafood. So we were looking at the constituents of the dispersants, the constituents of the oil. What is their potential toxicity? How long do they persist in the environment? How quickly are they picked up by seafood species that are live and swimming or not swimming in the environment? And then what is their disposition? How are they metabolized? How are they eliminated? How long do they persist in edible tissues? We were looking at that facet. We were not tasked with looking with environmental or ecological damage, so it was a very, very focused effort that the FDA put together. In terms of identifying the potential contaminants that would taint seafood and make it unsuitable for consumption and distribution and consumption, we went to work rather rapidly, worked closely with EPA, for example, in determining exactly what the metals and metalloids content of the oil was, from aluminum to zinc. We worked on determining what the PAH profile was in the oil. Here you can see as is typical for many oils, it's dominated for the polycyclic aromatic fractions, the naphthalenes, and of course the ones of greatest concern are the polycyclic aromatic hydrocarbons. Those are the ones furthest to the right. They typically make up just a few % of any oil. But it's still very important for you to have a profile of what the oil looks like, so you know what to look for if you're running analyses on tissues, whether they be seafood tissues or human tissues, fluids and so forth. So this was well characterized and looked at in detail before you developed the human health risk assessment, and then of course the full-blown risk analysis by which decisions are made in determining whether to allow seafood to be harvested, much less marketed and distributed throughout the United States. Protective measures that were taken immediately at the time of the wellhead blowout as the oil approached the shoreline was to close all oil spill impacted waters and both commercial and recreational watercraft and fishing. This was done in coordination with NOAA. They, of course, were projecting where the oil was drifting and flowing. So we were very closely coordinated in shutting down waters to harvest as the oil approached. We also closed areas that were expected to be impacted within, say, 24 or 48 to 72 hours in advance. And then, of course, we were also testing seafood, collecting seafood desperately, looking for that baseline sample. I like benchmark. That's a much better term for what we really were actually trying to do. We wanted to see what the levels were, what background levels might exist in different seafood species up and down the food chain before we began collecting after the waters were reopened again for harvest. And of course, the FDA did a lot of inspection of primary seafood processors and wholesalers to assure that they were not distributing seafood that was harvested from a closed area. Here we see a map of the closed area, the oil spill. All of those blue triangles are seafood wholesalers, distributors, and so forth that were visited by field agents of the Food and Drug Administration and were visited to discuss and bring them up to date on their HACCP plans, hazard analysis and critical control point programs that they all had to have on the books so that they were aware that there was an oil spill going on and that they should not be receiving and distributing any kind of seafood product coming from a closed area. This in combination with trying to grab up samples that were collected or seafood that was actually collected and harvested from areas that were going to be impacted was part of the initial days of the spill. Then, of course, we got together with the 5 states. This was a very, very interesting exercise. Getting 5 states, their fisheries department, their departments of fisheries and wildlife, their departments of health, together with the EPA, FDA, and NOAA on the phone at once, trying to hammer out a protocol, much less an agreement on, what we need to monitor for, how long we needed to monitor, how were we going to collect it, and so forth. It was at one time, I think we had 80 people on the phone at once. And it was just, it worked, but it was very messy at first. And it finally settled down. We finally found, who our leaders were within the different groups that were communicating. And we actually bumped heads pretty hard at first, but we came back and actually agreed on an established criteria for assessing seafood safety and the procedures both for sampling and testing to verify safety before the fisheries would be reopened anywhere along the Gulf that was impacted. It's not working. Oh, that one. No? Nancy, we have a defective computer. There we are. All right, this was a bit of a chore and a battle as well. I mean, we had toxicologists at the Food and Drug Administration, toxicologists at the FDA. They're all board certified, but there's many different ways to approach risk assessment. On the left are the 13 PAHs, polycyclic aromatic hydrocarbons, that were selected to be monitored in seafood. You've already heard from various speakers that there are thousands upon thousands of compounds in oil, and there are. So you can't really measure for everything, anything that might be toxic in the oil, because you wouldn't be able to get through it all. So you take a subset that is representative of the greatest risk. These are the PAHs, the polycyclics, and these are very typical, is a typical selection of PAHs that have been used in other oil spills and monitored in other oil spills. We took 13. You calculate their toxicity. You compare that to a benchmark, benzoate pyrene equivalents, and you come up with a number at the end. There was questions and concerns about seafood safety or seafood consumption rates that we adopted, also the body weights that we adopted, the duration, the dose, the exposures, and so forth. But what it all boils down to is that it's the toxicity, it's the dose, and it's the duration of exposure are the biggest factors involved in running a risk assessment. There are many different factors that you have to consider in terms of the duration of exposure and body weights and health conditions, susceptible populations, and so forth. But the bottom line was that the values that were calculated by the toxicologist for this particular outbreak are very consistent with those that have been done in the past. The next issue was to sample. NOAA, this is the Federal Waters Offshore, broke the closed areas into 90 30-mile by 30-mile grids, and then went out and started sampling. We also had vessels of opportunity out, actually fishing opportunity, collecting as well in some cases. And then in the state waters, which were actually managed by the states themselves, their wildlife and fisheries departments and public health departments, they broke it into 6 different regions, and they went out and collected as well. All of these samples, fish samples, upwards of 10,000, were collected and channeled through the National Seafood Inspection Laboratory in Pascagoula, Mississippi. And here's the sample flow that occurred during the spill. The sample was collected in the field, was delivered to the National Seafood Inspection Laboratory in Pascagoula, Mississippi. It's about 30 miles west of the laboratory that I was at Dauphin Island. It was processed and it was put through sensory assessment, the sniff test. The derisive comments that we got on the sniff test were, it's true, people just they were not listening, and it was not communicated correctly. Even elements of the media misrepresented what was being done. If you can smell oil on a seafood sample, why put it through several $1,000s worth of analysis if you can just reject it right away, keep the area closed, and then come back in a few weeks, sample it again until you have a clean something. Obviously, okay, this is worth spending the money for analysis. If it failed, it went back to a wait period. If it passed, we went on to chemical analysis, and we had different levels of chemical analysis that were involved. We typically would use gas chromatography mass spectrometry, which would give us specific details on each one of those PAHs in detail. But that method takes several days to conduct. It's a very laborious, involved method. It's been validated. It's a very reliable method, but we needed something faster to screen. So the different agencies got together and developed a fluorometric method using high-performance liquid chromatography, and that could be done in about 30 minutes. So we installed that and it used both along the way. Anyway, if it passed the chemical analysis using instrumental methods, showing us that we were below threshold levels of concern for those contaminants or potential contaminants in the seafood, then it passed, and then it went to the risk managers to consider reopening the area from which the sample was taken for commercial harvest. On an average level, all areas that were shut down in the Gulf of Mexico were closed for an average of 74 days, a month and a half, after the point where we saw no visible evidence of oil. Sampling didn't begin in any area until there was no visible evidence of oil. And then 2.5 months before the areas were reopened again. As the samples were collected, they were brought into Pascagoula. As I mentioned before, that's the blue star. And because of the large number, they were distributed across the country to different federal, NOAA, FDA, and Food Emergency Response Network laboratories. That's FERN in the top. So the analyses were taking place in Minnesota, Wisconsin, Connecticut, Washington State, California, all using the same identical methods that I just described a few moments ago. So it took a while to bring all these laboratories together as the oil was still coming out of the wellhead. We were on the phone organizing all these laboratories, trying to get them all lined up and spun up on the methods, because all the FDA labs in particular, they've got a backlog of analyses that each laboratory has to perform. We had to take them parts of their laboratories offline and then devote them to this, but we also needed help from the FERN laboratories, and that's what they are. They were designed and intentionally put together for food emergency response outbreaks like this. Here are the results. The the dashes are the levels of concern that were showed on that table of polycyclic aromatic hydrocarbons, and all of the symbols down below, multicolored, are the actual results that were recorded on the analyses. You can see that the levels of the PAHs listed on the x-axis on the bottom are below the levels of concern. There was critique of this, not of the results so much, but of the levels of concern. Some NGOs felt that they needed to run their own calculations to determine what really should be the levels of concern. But interestingly enough, a lot of the results that showed up, that came back out from those efforts, actually recommended levels that were out below the benchmark, the baseline levels that were already in the environment before the spill occurred. So we had to go back and forth on a number of those issues. Here's these results are from the state waters. and these are from federal waters. And last thing I would like to talk about is, in the last 2 minutes, is to bring a little perspective and context to this. We've talked a lot about not having enough baseline information, benchmark data. And it's true. Ecologically speaking, we don't have enough information properly across the food chain. But there was data available, and that's through the NOAA Mussel Watch database. And it's a sentinel species that's useful as a baseline. Started in 1986, 300 different locations around the United States and Alaska collect shellfish on a monthly basis, and they analyze those shellfish for about, I think it's 140 different contaminants. Of the PAHs, 65 different PAHs, including their alkylated homologs. And there's no time to talk about the difference between the pyrogenic and the petrogenic, but we could get into that later. And here is a summary of that. Here's a 10-year average of PAH levels in shellfish from the United States East Coast, the West Coast, and the Gulf Coast. The results might surprise you a little bit. Really, the higher samples with the higher levels have been found in the Northeast and the Northwest. 2 specific spots I'm not going to mention. But at any rate, this shows you the baseline, the background level, the benchmark, if you will. These numbers go back to 1986, so we had some idea, and this is in a shellfish. Shellfish will tend to accumulate any potential environmental contaminant more so than other species. They have the slowest metabolism. They do metabolize and excrete, but they're slower than crustaceans, finfish, and here, if you can take it all the way back here, I've shown this data. In the previous slide, I'm presenting it a little bit differently, going back to 1993, and you can see in the upper right of each of those plots, I have Deepwater horizon all species. That's the average of that particular PAH that was found in all species on average. So these numbers continued through the spill. So another issue that was brought up was the dispersant. Dispersant, as you've already heard, is composed of constituents that were selected because they were thought to be non-toxic. And indeed, all but one of the constituents in core exit 9500 can be found on the CFR Code of Federal Regulations as a food additive or as a consumer additive to a consumer item of one sort or another. Here I've noted, the CFR, the Code of Federal Regulations, the plus means there's a lot more citations in there. So so these things are common in our environment. It's not to say you want them in the ocean. Goldfish in a goldfish bowl don't like soap, they die. So it will cause harm in the environment, but in terms of its potential to get into seafood for human consumption, FDA was never really too concerned about it. And as a result, running analysis, because of the pressure brought to bear, we used dialkyl sodium sulfosuccinate. That's the item that is the most active. It's an over-the-counter laxative, so you can see why it was active. And these are the values that were found. This is not to say that it doesn't create an environmental problem. We heard someone talk about dispersant and oil being 50 times more toxic. Well, it's not increasing the intrinsic toxicity of the PAHs. What it's doing is breaking it down, making it more available. So that's what dispersants do. There's a difference. And that's the little subtle nuances of science that we had very difficult time communicating to the media and to the public. Because you have to have a gifted speaker, someone who can really explain science to a lay audience, to broad audiences, to really do that kind of thing. So my final slide was recommendations. I think we need to support long-term baseline studies of the ecology of our coastal waters and standardize our methods so that we can crosswalk them. We need to support the study of human environmental toxicology of petrochemicals and dispersant constituents, just to make sure that we've got our bases covered, that we're not endangering anyone, and prepare human health risk assessments and risk analyses ahead of time. We should be able to do this. We should have seafood consumption data from region to region to region. Do it while it's quiet, and let's go ahead and put together the risk analyses for different susceptible populations for the risk managers to have lined up before them at the time that we have the next accident. So that we can move through this a little bit more smoothly than we did the last time. And lastly, communicate to the public more often, more effectively, and more frequently using the technologies that we've talked about in the last few, in yesterday's conversations. So that's good.